Hello, everybody, and welcome to another edition of WAVY Science Lab. I'm meteorologist Jeremy Wheeler, and today we're going to be talking about hurricanes, and we're going to try and get some information on them and dig a little deeper into them and kind of get the inner workings of a hurricane. We'll talk about some past hurricanes and how they've affected us, and especially here in Hampton Roads, but also a couple that have affected the country in a big way. And we're going to have a little bit of fun, but I think today is just going to be so neat just to get into the science of this that probably be a little bit less jokes today and a little bit more of the science, which today you would think it'd be a good day to have a lot of fun and jokes. But I just got so much content, so many things to cover. So let's get to it, and we're going to dig deep into this and talk about the different hurricanes. So first off, what a hurricane is, just the basics of it. And so Hurricane Aaron, that happened a little while back. You can see the eye there, this enhanced satellite. So you can actually see the brighter colors show you the taller cloud tops and the colder cloud tops. And so that's why it looks like that. Sometimes you just see, the white and the green, which is, rain in the clouds. But this is enhanced satellite. So very cool to see. And so we're going to take a look at more satellites in a little bit, but first off, let's go to the very beginning. And, what is a hurricane? So a hurricane is a tropical cyclone that rotates, forms over the tropical or subtropical waters. And, a tropical cyclone, we'll back it up more, is a rotating area low pressure that has organized thunderstorms, but no fronts. So it's this, big cluster of thunderstorms, and it all spins, counterclockwise in the northern hemisphere, and it's an area low pressure. So it doesn't have any fronts. Otherwise, it's a subtropical low or post-tropical. Minimum sustained winds 74 miles an hour, and the eye has a center. Now, the name, the origin, Mayan, huracan, god of wind. I didn't get that. I got this from NOAA, by the way, National Weather Service, or National Hurricane Center, rather. The Caribbean tribe, the Taino, Huracan, I believe, Huracan. And then the Spanish, they got these names, and then they went back to Europe, and they said, to describe these storms, huracan and furacán. So interesting. And again, that's from NOAA. And then cyclone by itself is a Greek word, kuklos, wheel. They kind of derived it from that. So this is a hurricane. This is, of course, just a made up one. And so this is extreme area low pressure. You can see the center there as the eye is rotating around. And winds want to go into that center, but the spin of the earth makes those winds spin as well. And so, that's Coriolis force. And then we've got the rain bands around that as well. Now, we're going to do something different today. That's right. We're actually going to take a look at some 3D. So as long as I hit this right button and make it work, let's try it out. Let's use 3D to talk about hurricane formation. So what do you need for that? Well, you need warm ocean water. It evaporates, and then that goes up into the sky, and it cools and condenses into clouds. Now, these clouds can grow into some tall thunderstorms, especially if you have weak wind shear, which are those upper-level winds, and then those storms grow and expand, and those thunderstorms can make big clusters out over the ocean. So let's imagine that. We've got a cluster of showers and thunderstorms over the ocean. We call that a tropical disturbance. It's disorganized. Maybe there's several clusters rotating around a little bit, or maybe even go in different directions. But eventually, that area, the pressure drops a little bit, and we get an organized system to form with a circulation. Then you have a tropical depression. If the winds are below 39 miles an hour, once the winds reach 39 miles an hour, then it becomes a tropical storm. Now it has more structure. It doesn't usually have an eye, though. The storm gets a name at that point. Now, beyond that, once the winds get up to 74 miles an hour or greater, then you get a hurricane. You get an intense, organized system. You get an eye present. And so that is how hurricanes form. Woo, that boy is handsome, isn't he? Woohoo! All right. Hey, it worked. I hit the right button. Everything worked. That was great. That was fabulous. 3D stuff coming at you. You didn't think you'd have 3D stuff, did you? But hey, we do. So, that was. Let's use 3D. That was the wrong button. All right. So now we've got a hurricane, and let's talk about the structure. And so we've got all these different features here. You've got the eye, which is, usually hollow, right? Sometimes it fills in a little bit, especially on the top. And then you've got the ring of storms around it, the eye wall. That's where the worst of the storms are. And then that wind, it goes like a helix and goes up to the top, and then it spreads out. And you get that dense cirrus overcast over top of it. And then, of course, on the bottom, you have these rings with storms around it, the rain bands around that center. And so that is the structure of a hurricane 3D. Here's kind of the cross section. And this is you see in the eye, you got the eye wall there over the warm ocean water. You can kind of see how those winds behave around that feature. So very cool stuff. I mean, when you're looking at this, you're noticing just all kinds of different circulations around it, and I'll back it up here as well. It's a complicated structure. It is a very complicated structure, how it all works. You may ask also, well, why does that center become hollow? Well, the winds are spinning so fast in some of the hurricanes that the centrifugal force is trying to push out the wind while, the winds are coming in. And so that's what creates that ring, that hollowness, because the centrifugal force is going around so fast, the winds want to spread out a little bit, and it does. The force expands it. And so that's how that eye behaves and that forms. And so in an eye, I mean, you can go in there and look up and see blue skies. So some of the ingredients that you need, of course, are warm ocean water. We talked about that. Water temperatures above 80 degrees. And converging winds at the surface. That means they're coming together, basically. They're coming in, meeting in the middle. And so that's that. And then abundant moisture as well. You need a lot of humidity out there. You think over the ocean, plenty of humidity. Well, sometimes dry air actually comes in. Sometimes you get dry, dusty air from Africa, and that will rob it of its moisture. Sometimes cold front will come in off the United States and do that. Upper level winds, wind shear. You want light wind shear if you want a strengthening hurricane. So there's those warm ocean waters. And again, you need water temperatures generally about 80 degrees or higher. And, last year we had, I think water temps were in the upper 90s or something off Florida. It was kind of wild, not this year, but still. And so that is an ingredient. And then the hurricanes, they strengthen. And so here's the Saffir-Simpson scale, the hurricane wind scale. And so those winds, they start at 74 miles an hour, get up to 95, and then the corresponding winds go with those. And but they don't go with the same storm surge. They quit that years ago. They kind of had a storm surge category for each one, but there were too many examples of where it just didn't work. Isidore, I think, was one of them, and then the Nor'easter '09, I think, was kind of another one. So, and then they use these cloud techniques called Dvorak techniques, and so they use those to try and figure out how strong a storm is. And then they also use other things as well, but this is kind of a tried and true technique. Okay, so coming up, we're going to take a look at some more things here in just a little bit. We'll look at kind of a little bit more about Aaron. We are back, and so we had a successful, first round there. That was great. We got the 3D to work, so that was wonderful. So now we're going to take a look at some more fun things, interesting things with the hurricanes. Of course, I say they're fun. At the same time, they're very, dangerous, and they cause a lot of problems. They cause a lot of harm. So, I mean, it's good to understand them, though. So we had Hurricane Aaron. I showed you the satellite off the top there. This is from a little while back. And so the interesting thing about Aaron was it was one of the most rapidly forming hurricanes in Atlantic history. I mean, take a look at this thing. At one point, on the Friday morning that it was active, it had winds of 75 miles an hour. So it was a Category 1. You look at, 24 hours later, 160 mile an hour winds, explosive growth. This is what we're worried about these days with global warming and warm ocean water temperatures. These things, they can do this a little bit more often than they used to. And that's what's scary, because let's say we have, a Category 1 off the coast, which happened before, and then all of a sudden, next thing you know, it's a Category 2 or 3. That happened. Was it another Aaron? There was another hurricane where it actually did that off the coast of Texas, and I wish I remember which one that was, but maybe Patricia. I'll have to look that up. But the bottom line is Aaron did stay offshore away from us, but we still had effects here. We still had, tidal flooding. We still had some wind, and it wasn't purely from Aaron. There was a high pressure to the north, but it did move away from us rather quickly and became what we call post-tropical, and it turns into an L. That means that it loses its tropical characteristics. Now, here's the cone of uncertainty, and they did a really good job. The National Hurricane Center did a really good job at putting that up there, or following it and, doing the tracks. And so, this hurricane cone is made up of a whole bunch of circles. And so they connect those circles. So let me back this up a little bit and kind of show you. So the bottom line is, you see how it's round at the end? That's the last circle. And there's a whole bunch of circles that are connected. You just don't show them. And so the circles represent the average error over the last 5 years. And storms travel within that cone 2/3 of the time. So, of course, if there's more uncertainty, usually the cone is a little thinner, and the more uncertainty, the cone is thicker. Less uncertainty, the cone is thinner. And so they do that. And by the way, I forgot to mention that hurricanes are in the east, in the Atlantic and the East Pacific. Typhoons is what they call them in the West Pacific. Cyclones in the Indian Ocean. So those are kind of a recap of the names that I was supposed to do a little earlier. But hey, do what we can. All right, so let's take a look now at the Aaron. This is really interesting. Meteorologist, I believe Don Slater imported this. And so this is the hurricane hunters. They flew into the eye of Aaron. That's it. You remember how it's hollow in the middle? Well, there you go. It was a stadium effect. It looks like a big stadium. And so, yeah, I mean, that's it. That is Aaron in the eye. And they flew right into it. And, I mean, you can clearly see it's clear skies above. And then, you get in a little bit. There's the plane propellers. So these hurricane hunters, they do a great job. They really do. They're invaluable. And so here's some of the planes that they fly. The WP-3 Orion flies into the eye of the storm, ceiling 27,000 feet. The NOAA G4 that flies at high altitude. I've been on that one. I think I went on the Orion as well when they came into Norfolk years ago. And then the WC-30 flies in the eye of storm as well. And we're thankful for that. And, they do a great job, and they're very safe. And so we appreciate that. Now, let's have a look at the hurricane climate. And it peaks in September, early September. And I'd say, it's still very busy from late August all the way through early October. After that, then usually things drop off quite a bit. Sometimes you can still have some busyness, as you can see, especially the tropical storms. But sometimes you get a hurricane all the way through November, and even into December sometimes you can get a hurricane. That's rare, but that does happen. So these hurricanes, they have strong winds and they produce a big tide. So you get this normal tide on day to day, mean sea level, and then you get predicted tide in the dark blue. And then on top of that, you get the storm surge. And so that storm surge, we have to calculate that. We don't do it here at WAVY, but, the National Weather Service and the National Hurricane Center, they calculate it. And then they tell us, and then we tell people, hey, we think the water is going to rise up to this level, that level. And so that storm surge, it starts off pretty low, but then it starts building up. That wind gets stronger, especially when the storm gets closer. And then it also depends on what's called the bathymetry. Ooh, that's a little technical. The surface under the water. So, you got to factor that in. For us, we got the Chesapeake Bay. Water funnels into that Chesapeake Bay, and then you get the flooding, far away from the center of the storm. And so, this is just an example, 12 feet. It can be different levels, of course. It can be a couple of feet. It can go up to 9 feet. During Hurricane Katrina, the water levels got over 20 feet. And then there was another one down there, Michael, I think the water got about 20 feet. Now, we haven't had that type of level here. We've not had that. We have had some pretty strong levels, though. I want to show you this. I'll probably show it again in a little bit, but this is the record high tides. Isabel, the level got up to 7.9 feet. 1933, it was 8.02 feet. And then, so that was an old historical one, but Isabel was the second biggest. And then the nor'easter of '09, that is another one that I was in. I was here during that time, and we were coming into the TV station, and then we got part way, and actually, pardon me, let me back up a little bit. We went to the fire station down the street. They brought us in a big fire truck, a hazmat truck, and then, big wheels that are, this tall off the ground. I mean, several, not several feet, but it was very tall. And so that got stuck. There was a recess, and it got stuck. So they actually brought a boat out and brought us into the TV station. It was Nor-Ida, because it was Hurricane Ida at one point, I think, and then it turned into a nor'easter, basically, a giant nor'easter that lasted for days. It sat off the coast for days. And so we, when we came into the TV station, we had to work. We had to wade through water, and it was just incredible. And the water level got so high. So that was, again, the level there for the nor'easter of '09. Then Irene 2011, that was another bad one. We had a hurricane that came through here and caused a lot of damage, a lot of I don't remember if there were any deaths, but there was a lot of damage. And then Sandy was a historical one, 2012, 6.81 feet. So that is from the storm surge from these storms. All right. So what we're going to do is we're going to take a break here in a little bit, and then when we come back, we're going to talk about more historical storms. We'll talk more about some of the features they created and some of the damage and some of the unfortunately some of the destruction. And we're going to talk about some that affected us, but we'll also talk about some that just impacted the United States, some big ones. And so that's coming up here in just a little bit. Don't go away. We are back, and we are talking about hurricanes here today, some pretty interesting things and some pretty interesting sight and sounds. We had the 3D earlier. Now we're going to talk about these hurricanes, and we'll talk about some of the effects from historical hurricanes. So let's take a look at that. And first off, we're going to start it talking about the top 5 strongest hurricanes in terms of wind. So 190 mile an hour winds. Hurricane Allen, 1980. I mean, think about that. Almost 200 miles an hour. I mean, NASCAR drivers drive almost that fast, or they probably do drive that fast in some cases, right? Even faster than that. So, but still, I mean, it's that fast. And then the Labor Day hurricane, 1935. It's so long ago, but that was actually a very historical hurricane. Did a lot of damage. And then Hurricane Gilbert, 185 miles. Wilma, 2005. I was around for that one, and 185 mile an hour winds. Dorian, we'll talk a little bit about Dorian. Out over the water, it was 185 mile an hour winds. It actually hit our coast and moved up along the Outer Banks. So that's one that we'll talk a little more about. So first off, I want to talk about, this is Andrew. So this is the radar, and radar, I'll describe it, but that's the eye. You can see the eye there, passing south of Miami, and it caused major damage because it was a Category 5. It was a Category 5, 1992, so that was a radar. And so some of the damage, it just wiped things clean. I mean, there was nothing left. Well, there's debris left, but there's no structure left hardly at all. And that's what a Category 5 does. It just cleans house. There's nothing left. And Hurricane Andrew, was one of the strongest hurricanes to hit up until that time. Camille was one in 1969. That was another one. So that, did a lot of damage. But this Andrew, it was kind of the first time we really had cable. And so, things were coming in with it, and we had the Weather Channel, things like that. And so we got all this media coming in for the first time that, outside of just the regular newscast. And so it was really something to see that Hurricane Andrew. And I remember that. That was something that made headlines. It was in the news for a long time, of course, and as it should be, but it was just really incredible. So this is the track of Isabel, or pardon me, this is the track of Isabel. Pardon me, I changed gears a little bit. So Isabel hit here. That was not nearly as strong. It was a Category 2. I believe it was a Category 5 out at sea at one point. Let's back it up a little bit. Yeah, so it was a Category 5 at one point, but then as it got closer, it became a Category 2, made landfall, and then we had a lot of problems here in Hampton Roads from that. That was before I got here. It was the year before I got here, but boy, everybody talks about Isabel. So there's, from WAVY.com, some of the wind damage. You can see that, just getting knocked over, the trees onto homes. This is the pavilion that's out by us. We had some pretty bad damage on that. The awning got blown off. It was made to withstand strong winds, but they were, I guess, just stronger than they thought. This is the flooding from Isabel. We had a lot of tidal flooding. We had a lot of heavy rain. Midtown Tunnel flooded. So now they put up those gates, the floodgates. So that was Isabel. Let's compare that to the track of Isaias. Isabel was 2003. Isaias was a few years ago now, 2020. And so Isaias, that didn't have the same type of problems. It was a weaker system, but it did cause a lot of tornadoes and a lot of damage from that. EF1 in Suffolk, EF3 in Bertie County. And those, I was here for that one. We were covering those tornadoes. So Dorian, I mentioned that. Yeah, out at sea it was a Cat 5, and then it weakened quite a bit. But it moved through here, and we had one reporter, I believe Jason Marks, he held up an anemometer in his hand, and he recorded a wind, I believe 89 miles an hour. And he was standing to that. He was trying to push up against it. Really something. And that, there's some footage. I don't know who filmed this. It was on WAVY, because it's on the logo there, but just that's some of the flooding from Dorian in 2019 and some of the wind that was around it as well. So, yeah, that's amazing stuff. Now, this is Hurricane Matthew, and Matthew was 2016. We had heavy rain before that point. We had heavy rain out there, lots of it before it hit. And then I say hit. Here's the thing. Everybody thinks it hit. Really, it did miss. And I thought it was even a little bit more offshore than the track here. But it was offshore. It did not move over land. But it interacted with a stationary front. And so that caused a lot of our flooding up here. We had basically one giant flash flood. And so there it was, all north of the track. Look at that. The heaviest rain was well north of the track, away from the center, which doesn't usually happen in a tropical system. It usually happens around that center. So that's really something. And then Hurricane Sandy, 2012. This one, was just a monster size storm, became post-tropical, a huge system, a huge nor'easter system with kind of a heart of a tropical system. And it really hit up around Jersey in the Northeast, but it affected so many areas. We had flooding here. We had, some storm surge. And then Katrina, one of the most famous ones, one of the most destructive ones of all time. The winds actually weren't the most destructive, but the flooding down around New Orleans and southeast Louisiana and Mississippi that was legendary. The storm surge got over 20 feet, and so it did that. And so the worst part of the storm is the eye wall. That's where, in terms of the wind, that's where the winds are strongest usually. And so you get those winds to just do some major damage. And it's almost like being in a tornado for a long time, or I guess it's maybe not the best to compare it that way. And then you get a hurricane watch issued up to 48 hours in advance. Conditions are possible. Prepare your homes, get things ready. But you get a hurricane warning in 36 hours. That's bad stuff. I mean, the hurricane force winds are expected or likely, and so it's time to sink or swim. Maybe that's not the best analogy, but prepare to hunker down if you're ordered to evacuate. All right, so let's do the environmental tip of the day, and this one's kind of a quick one. Hopefully you had some fun there with all the hurricane stuff, or at least learned something. But so let's switch gears now. Environmental tip of the day. If you're shopping online, combine your orders into a single shipment to use less packages and boxes. It's a great idea. You want to try and use as little as possible. So much emphasis on recycling. Well, that's great, but try and reduce and reduce how much you use. If you're in the store, you could possibly choose no bag or a package if possible. So those are just some tips that you can use there, and try and just use a little bit less, right? Use less, then there'll be less in the recycling if they do that, because they don't recycle as much as they used to, or less in the landfills. All right, I'm meteorologist Jeremy Wheeler. Thank you for joining us today. Hope you had some fun, learned something, and we will have more episodes forthcoming with more interesting topics. But yeah, the hurricanes, very serious stuff. We did have a little fun, but hopefully you just got to see how impactful they are.